This is for Year 11 methods. We're going to look at question 2 from the chapter review, extend response section. Okay, so we've got a scenario where we've got an equation given to us and it relates to lenses and distances from lenses. We don't really need to understand the concept too much, the context too much, because it simply is a rearranging question. Find R in terms of U and V. Okay, so it means make R as a subject. Okay, in order to make our subject, let's write the equation down and rearrange it. Okay, 1 plus V plus 1 plus 1 on U equals 2 on R. Now, I want to combine these two fractions because I want to do a flip later on. Okay, the reason why I want to do a flip is because R's on the denominator, and that's never a good place to be when we're rearranging. Okay, if I combine these two fractions together, the common denominator will be U times V, or UV. Okay. Now, in order to achieve this, I have to multiply the first fraction by U on U. It's like saying multiply by 1, and you multiplying that by V on V. Now, when I do that, I get on the denominator, the numerator of this one, I'll get U, on the numerator of this one, plus V. Okay. And if you break this fraction down again, you'll get back to what you had originally. Now I'm going to do the flip because I don't want the R on the denominator. So we're going to flip the fraction. So go UV, U plus V equals R on 2. I'm going to multiply both sides by 2 to get R on its own. So we get R equals 2UV, U plus V. Let's read whether we've done what the question asks. It says find R in terms of U's and V's, and we've done that. Okay, so we're happy. For part B, find M in terms of U and V only. Okay, what's M? M is given by this formula. So M is equal to V minus R on R minus U. Now, we don't want R's because it says we want it in terms of U's and V's only. So how do I get rid of the R? Oh, hang on. In the previous question, we've written what R is in terms of U's and V's. So it's basically a sub-in question. So we go sub-in, we go V minus R. So instead of R, we put what R represents in terms of U's and V's. So it's 2UV on U plus V minus 2UV on U plus V minus U. Now, obviously, this isn't very tidy. So we want this fraction to be nice and tidy. We should have one denominator and one numerator. Now, the way you tidy this up is that we want to combine, we want to make this into one fraction and want to make this into one fraction, then simplify further. Okay, I'm going to do this on the side just so you know. V can be changed in terms of U and V because we want the same denominator. V can be changed in terms of, if I multiply the top by U plus V, then the bottom can be U plus V as well. The reason why we want to do that is because we want it in terms of U plus V. Okay, so I'm going to create one fraction there. So we're going to go V U plus V on minus 2UV because that's here, divided by U plus V. Okay, I'm going to do the same thing here. So for the minus U, I'm going to times it by U plus V on the top and then U plus V on the bottom. So we'll get 2UV minus U plus V, all on U plus V. Okay. Now, since they're both on U plus V, we can disregard them. We can just go, this is the denominator, this is the numerator. So M equals VU plus V minus 2UV on 2UV minus U plus V. I'm going to expand and simplify. Okay, so VU plus V squared minus 2UV on 2UV minus U squared minus UV. We can see that I can simplify. I can simplify because these are you got UV minus 2UV, so we're left with V squared which is here, minus 1UV, and the bottom one we've got UV 1UV because we've got 2UV minus 1UV, minus U squared. Okay, and I believe that that's as far as you can go with the simplification. Okay, hopefully that helps.